Do we want to put it anywhere else?
No, I don't have like a social media presence or anything like that, so I don't really know.
Great. I'm just gonna tweet it. Okay.
Hang on, I'm just going to look at the YouTube page and make sure. No, that's the wrong thing. I just want to make sure that we are actually visible.
Good question. Here's, do you have the link to it?
No.
Here's the link.
Okay. There we go. Yeah. I see us.
Okay, perfect.
A couple of seconds delayed.
Awesome. Okay. So I put some stuff together for us today. I figured we'd start by I'd start by talking a little bit about what is in these guys and what we're going to be doing with them and how it works. And then we could look at a recent pull request as like as a first way to kind of get started and test it and see if it's working and then merge it and then try for some of our own functionality. Does that sound good?
Yeah, sounds great. Yeah.
Okay. I'm going to share my screen with you because I have a couple slides. One second. Okay. Okay.
Yeah, I see it.
You got it? Okay, Okay. So the technology that lives inside these little Jewelbots is pretty advanced in the way that it uses some fairly bleeding edge technology. The important part when we were designing the process was to figure out what what we heard from our users was that they really wanted a way to communicate with each other and signal their friendship. And so that was how we went into it. And so knowing that that's something that we could do. So when it comes to radio devices, there's a few types of radio you could use. You can use Wi-Fi, you can use infrared, you can use Bluetooth. We ended up testing a bunch. We ended up landing on Bluetooth because Wi-Fi you need to configure uniquely for every situation that you're in. So that works well. Wi-Fi works well when you have a phone or a cell signal, but not really.
And a UI with which to configure your Wi-Fi thing. But if your UI is a button, then that's that's probably a bit harder to.
Yeah, exactly. You'd have to do like your password in binary or something like that. Yeah, and we thought about infrared a lot. In fact, there's a really cool company called Pixmob. They are the company that makes the bracelets that you get at concerts. Have you ever been to a concert where everyone gets a bracelet or you like a lot of times in big sporting events like the Super Bowl here, you'll see like lights in the audience that will go with the music.
Yeah.
That's a company called Pixmob. They use infrared to control those devices. So basically, the way it works is it controls by location based on where you are in the stadium. So the bracelets look for the infrared signal and just basically react in whatever way of like what they're getting.
I'm kind of surprised that works for a bracelet because you can't necessarily like infrared. You have to be able to physically see the thing that you're connecting to, and so like in a crowded stadium, unless there's infrared transmitters like all around, I suppose. How does it work?
Basically it. Yeah, there's a lot of infrared transmitters pretty much everywhere, and people don't notice them. But if you like look, you'll see them. We actually had a big conversation with them during our design process, as what we heard from them was they tried to use Bluetooth first. They thought it made a lot of sense. But the problem is when you have thousands of people all trying to connect on Bluetooth, it becomes really slow. Oh, yeah.
Bluetooth is there's usually like an owner and a client, is that right? Like when you connect something to a Bluetooth, it's typically there's a device that is like in charge of the connection, which is the laptop or the phone, and then there's the client device, which is the headphones. Does it do peer-to-peer as well?
Yeah,
Bluetooth.
so that's the interesting part about the technology
Uh-huh.
that we're using. So usually something is either, like you said, a central device or a peripheral device. And
Yes, that's
that's
the word that I was looking
nearly
for.
all the technology you have now. What's unique about the microprocessor that we use is that it can have 8 simultaneous relationships
Yeah.
with
Uh-huh.
being either a central or a peripheral
Uh-huh.
device.
Uh-huh. Uh-huh. I
Um,
see. I see.
and so that was what was so appealing about this microprocessor in particular, because we knew we wanted to give the ability to talk to a bunch of different friends, and we
Mm.
thought 8 was enough. And so far it has been. We haven't run
No
into
one has
anyone
more than
that's
eight
like,
friends.
yeah, we haven't run into anyone that's like, I have 30 friends and I can only be friends with 16 of them. Um, so, so yeah, so this is if you look under the hood, this is what you'd see. Those are some early prototypes in the middle. That's a
Yeah.
quarter for size. So the ones in the middle were boards that were not custom for us, but had the functionality that we were looking
Right,
for.
right, right. So you were just sort of prototyping with this thing that was not going to fit in the device, but see whether it works at all.
Yeah, exactly. And so that's what we did to get feedback. And then we played with lots of different plastics and things, which was interesting in of itself. Who knew there's so many types of different plastics and colors?
Mm,
That was an interesting part of the process. To get so, for example, the top makes it water resistant, not waterproof, but water
hmm
resistant, and where it creates a seal that
hmm
allows it to go into like up to 3 feet of water.
mm.
And that's something that we had to test a lot by throwing these things in cups of water. Uh, um, so if you look under the into the actual on the actual board, you'll see the our microprocessor, which is 4 millimeters by 4 millimeters. I always say that if I ate it, I'd have no idea because it's so small. And it has very little memory, very little RAM, and so that's something that we've had to keep in mind throughout the design process is how much can we fit on this actually. And
It says on the slide 256 or 128 kilobytes of flash. Is
yeah,
that because you have two models?
yes, we don't have two models. We have the 256. I think this was a copy paste job.
Ah, I see, I see, I
So
see, I see.
yep. Um,
So the manufacturer makes two models, but you went for the 256 one.
yeah, exactly.
Right, right.
Um, One thing that I found really interesting about the firmware process and learning more about people who write firmware is I heard there are like no one goes to school to become a firmware engineer, first of all. Um, and there are two distinct types of firmware engineers. There are people with a software engineering background, and there are people with an electrical engineering background.
Mhm.
And the way they write firmware is really different and
Oh, that's
interesting.
interesting. Mm.
Like software engineers tend to write really clean code. Um, they consider object orientation. They kind of dry principles, that kind of thing,
Hmm.
which allows for things that are super readable and maintainable, but not always the smallest version, or it can be kind of
Right,
verbose. Uh,
right.
where people that come from an EE background write really ugly, super functional code
Hmm.
where it's not as maintainable maybe or readable, but it's very small and has like a small footprint.
Mm.
So I found that really interesting when we were learning
Mm.
about the process of who writes firmware and
Mm.
what is it like. Um, so one thing that we really wanted to do is make an open source piece of hardware, um, which is uh, which is there's not a lot of open source hardware, and that's a whole nother conversation in itself.
Hmm.
In the world, you can see through the world of firmware how much not having open source has hurt the industry in general. Places, for example, places where documentation is wrong, or places where things are
And you can't fix
inefficient.
it because you haven't got a community, right?
Yeah, exactly. And it just doesn't get fixed.
You
Or
just have to hope someone notices and submits a bug report, or you may not even have a bug reporting process because many big old companies don't.
yeah, yeah, exactly. Like, who cares?
Yeah.
Like, I'm selling something to a lot of people, and I care if Samsung is having a problem, but I don't care if, like, Benjamin is having a problem. So, like, if Benjamin writes me 6 times with the same problem, I might answer him, but in general, I don't really care. And so what that's done to the industry, like, there's not a lot of innovation in firmware. It's just, it
Uh-huh.
is what it is, how it is,
Uh-huh.
which is, hopefully, will change as there is more open source hardware, but there's not a lot. It's very little.
So when you say open source hardware, are you referring to like the schematics for the devices being open source, or just you purely mean like the firmware?
Both.
Both.
Technically, to be open source hardware, you're supposed to have both
Right.
open, and we have both on our GitHub.
So is
Um,
there? I know that open source software has been around for a long time, and then there's this sort of this quite vibrant legal industry around all the different types of licensing and all that stuff. Is that are there any like legal, like, how to put this? Everyone who works in open source knows to license your stuff under the MIT license or whatever, right? Knows about the main types of software open source licensing and how to choose between them, or at least it's easy to find out about that stuff.
mhm.
Um, is the sort of legal situation around open sourcing hardware presumably you can't just use the MIT license because the MIT license talks about software. You see what I'm saying?
Yeah, that's a really good point. And I don't think there's a solid answer for it yet. There's a whole community around open source hardware. It's not very big, but there's a conference and everything.
Mm,
Um, and people talk about this kind of thing. But in the world of open source hardware, generally has come from people that have a software background and just
mm,
switched, right?
mm,
Like, they've done open source hard software, and then they find the world of hardware, and they're like, this is stupid. I'm just going to open source it. So,
mm-hmm.
for example, there was a project called, oh, I can't think of the name of it. There's an open source microprocessor that compiled JavaScript,
All
um,
right.
and got inherited. They were inherited by the Node Foundation. So
All right.
which was originally, or the JavaScript Foundation was originally the jQuery Foundation.
Mm,
Um, kind of uh, took them on to become part of their open source, like, stable of things.
mm-hmm.
So it's very similar to software, and there isn't any that I know of hardware specific stuff yet. But the stuff that you find that is open source hardware is generally fairly hacky or hackable. Like,
Mm,
it's not Samsung, or it's not any of these big companies coming out with open
mm,
source hardware because they don't
mm.
care.
So when you published your schematics and your blueprints, or your PCB diagrams or whatever it is that you published for Jewelbots, how did you license it, or have you just not bothered to license it?
We use MIT. I'm pretty sure we use MIT. We use the
Mm.
one where you can't make money off of it, but you can use it. That might
That
be MIT. That
that might no MIT's anyone can do anything with it. I think you might be thinking of um uh, oh, I'm completely blanking.
I know. I want to say, like, JPL, but that's like a brand of electronics. It sounds like
I don't know. It doesn't matter. There's
yeah.
there's there's one type of license which you should basically never install a library that uses that license because you could get sued. Um,
Well, that's our goal, really.
you
We're like
want
a
a bit of
honeypot.
control.
Yeah, yeah. Um, so yeah, so the goal here always was to make writing for the devices really accessible. When we heard that there was a Nordic chip, and, like, that's the manufacturer chip is Nordic,
Hmm.
that you could use with you could use a
I lost you for a moment.
sorry, yeah, am I
Wi-Fi,
back?
Wi-Fi dropped out. Yeah, you're back.
Okay. When we found out there's a Nordic chip that you could put a Arduino compatible library on. That was really appealing to us because that meant we didn't have to write our own IDE.
Mm,
There are
mm,
few open source hardware projects that wrote their own IDEs, and that's hard.
mm, mm.
Um, yeah, sorry, go ahead. Were you going to say something?
Well, I was just going to say, so they have got like a, you can plug in an Arduino script into there. So it's not literally an Arduino that's running inside this, I assume.
Mm-mm. Yeah, no,
It's the Nordic chip, which is Arduino compatible. Is that right?
it has a library. Like someone wrote a library
The
for it.
shim. Yeah.
Yeah, exactly. Yep. And so when we heard that, we were like, okay, this is definitely what we want to use. We want to make it Arduino compatible.
Mm,
So what we did is the first step was write the firmware for the device that makes it function in the way we want it to. So the way they work is they work like a little beacon. So they are constantly polling the room to see if it has any friends nearby. On
mhm,
the device, there is a list of machine IDs or Mac IDs of devices it has paired with in the past. So it's a two-way consent when you're pairing with another device, and once you've done that, the device records the device it pairs with,
mhm, mhm,
and what color was picked, the
mhm,
friendship color. And so when they're in their default state, they're just constantly polling the room to see, do I have a friend nearby? Do I have a friend nearby? And once it does, it turns on the color of the friendship. And so, and then there's a messaging component as well where you can send secret messages. And so that's the default firmware on the device. But there's also a sandbox part of it, which is the API that we worked on after that.
mm,
And so when it comes to writing firmware, the stuff that you end up having to write is fairly esoteric and not super human readable.
mm,
For example, this set LED state handler, this function is basically something that you have to call. It's actually an abstraction on another function
mm.
that allows you to send information to the devices. We knew that we would not have 7-year-olds playing with this code, right?
Yeah,
So we had to
yeah.
figure out how do we make it readable and writable for kids. And so what we did is basically it's an abstraction on the API, which is our the library and the board library that our users use. So for example, to turn on an LED, you pick the LED position. That was actually a big debate whether we would do north, south, east, west kind of thing, or 1, 2, 3, 4. I lost that one, and we're doing north, south, east, west. I still think 1, 2, 3, 4 makes more sense, but um, you pass in the which LED you're using and a color. Um, and it calls a set light function, which
Mm,
is below
mm.
it, that passes in the RGB value of the color.
Right.
And then it calls that set LED state handler. Um, so where you see on the first line of the set light function, you'll see that there's 4 options being passed to set LED state handler. So that is a number which corresponds to which light, um, a red, green, and blue value,
Mhm,
and a number which is basically on or off.
mhm, mhm.
Um, so that's how we set up the turn on light function. And
Can you tell
then,
me the LED state handler again? Sorry.
yep, that's a larger function that we can actually look at in the code.
So, okay, yeah, good idea. Yeah,
Yeah, we'll do that next.
I'm just trying to understand the signature really, because like you declared an array and then your part. Well, it's a pointer, so an array is a pointer, I suppose. In C++, I've never written C++ before, so I'm just trying to
Yeah,
like put it together in my head. That's all. Well,
yeah.
we'll come on to it when we look at the actual code.
Yeah. It's really yeah, it's interesting stuff. I'm excited to show you. Um and so here is the color label lookup for the different labels of colors. Um and you can see that they can use uh, regular color words for colors. Something that was neat that happened earlier this year is one of our users um, found this in our firmware. She's 10. Found this in our firmware and also found a chart with RGB light values and started coding her own colors. So based on her work, we added a whole bunch of new colors. We used to just have like
Excellent.
6 colors, and now we have a ton.
That's great.
Yeah, and that's what we're going to look at today. So
And so did she make a pull request on GitHub and
we did it together. I showed her how to do it. Yeah, there's like a
that's
video of
great.
us doing it. It was really
That's
great.
so
She's
cool.
awesome. Yeah. Yeah, her dad works for Microsoft, which is really neat.
Right.
Um so yeah, so that I think this would probably be the first thing that we look at. This is some more examples, but I think we should probably um jump right into the light code. So why don't you if
Oh,
you
someone's being blamed. Oh, you can't mute tabs anymore. They got rid of the mute tab functionality. Sorry.
Oh, I didn't even hear it.
Someone's being blamed. Wheel music off. And usually I would just mute the tab, but they've taken it out.
Really?
Which is like the best feature of Chrome. You can mute an individual tab. Anyway.
I never knew you could, so I'm not missing it now.
It was in the flags. You had to turn it on, but I use it all the well. I used to use it all the time until today.
Now you're going to hear the blames always.
Yeah, exactly.
Okay, so why don't we so probably the best thing to do is I'll take us over to the GitHub and kind of give it a quick tour, and then you can clone the repository locally and we'll switch over to your machine. Does that sound good?
Yeah,
Okay.
sounds great.
Okay. Okay. So there are 2 libraries that control the boards on the devices. The reason for the 2 libraries is one of them turns off the friendship functionality. Because if I'm doing something with lights, and a friend comes around, and it becomes very confusing, we found. Why is my device not doing the thing I programmed and it's lighting up for my friend? So
I
having
see. Yeah, I see.
2 different ones made sense. Like, this is the library you use if you don't want to code with friends, and this is the library you use if you want to add things to the friendship functionality. So I'm just going to go into the regular library. Ellie Galloway that was her patch. So I'm going to go into the course.
Could you zoom in a little bit, please?
Yep. Well, that's a lot bit. Why isn't there a middle? All right. Oh, because it's going to 200%. Let's do. I can only do. Sorry, I'm new to Windows machines. Magnifier. Okay.
Oh, just use the Chrome zoom. I think it's Control Shift Plus. Yeah, there you go.
Okay. So here is a lot of the code that controls the device. So to see the function being used that we looked at before, we can go to the led.cpp file. And let's see the turn on the set light function. Okay. So this is a set light function that we were looking at. We turn on the light and we're using the set LED state handler. So all in this particular file, led.cpp, this is all the Jewelbots specific API stuff. This is the stuff that's open and accessible to the rest of the world.
One question I had, which is probably a C++ question, is I ran the code sample on the website and it has you declare an LED variable, but you don't initialize it to anything. So how does that work?
You declare the LED variable because
and then you can just start calling methods on that thing without ever like assigning it.
Right. So it's basically you're creating an instantiation of the LED library. So in this case, it's the namespace LED. You're calling the namespace LED, and LED has several functions that you can call on top of your variable.
Yeah. But what I was confused about is you don't say LED equals new LED. You just declare it and you don't initialize it. That's what I was confused about. It's a C++ question probably. Is like
Yep.
you don't have to actually create a new one. It does it automatically. Is that right?
Yeah, kind of like I believe C# does this too, where the getter and setter is already set. So this is the setter for LED. Or this is one of them is the getter, one of them the setter. And so it's in order to create a new instance, you don't need to say LED equals new
Right.
LED.
Right.
Yeah.
In C# you always have to say new.
Oh, interesting.
You always have to actually create the object. It doesn't ever create something behind. Well, it's not strictly true. It does if it's a struct, but whatever. Yeah. Okay. Yeah, that makes sense. So this empty constructor on line 29 that just gets automatically called behind the scenes, does it?
Yeah, exactly.
Right.
So to go behind the set LED state handler, because ultimately all of these functions uh, come back to calling the set light function. So even here, flash all, you'll see turn on all color, and then turn on all calls the set light function for all the LEDs. So this set light function is just the what is turning off and off the lights, on and off. I said off, like a very New York way.
On and off.
On and off.
I'm walking here.
So we have the LED state handler, and so in order to see how that is working, I'm going to go into the specific code. This in here is where the code that is specific to our to the chip lives, and to find it, I believe it's an LED driver.c. Something that is interesting that you'll notice is that the code that's specific to the microprocessor is written in C, and the Arduino compatible code is C++. So let's find.
So is this a library from the manufacturer then, the LED stuff? Right.
Yeah. And like, look at this stuff, right? Like this is ridiculous. This is what they're shipping. Some of this is like comments that we've written, but like some of it is just like them doing stuff and then leaving it in their library.
Right. And you have to just hope that you can understand what what they're saying.
Exactly. Okay, so here's the LED state handler. So this is how you make a pointer.
And what's this LED command T?
So that is, we're passing in the options. So
yeah. So I understand that it's the type, but I wanted to see where where this type is.
Where the type is set?
Yeah.
Yeah, good question. I bet you it's either
It's
here.
probably in this file.
Yeah. Nope.
Nope.
So it might be in LED. This is LED driver. It's not an LED sequence. It might be in utils. Let's take a look. It's a good.
What are the H files?
.h. So these are header files, and they define the functions within your .c file. So if I go here, it shows me here are the functions I have within the .c file. I imagine this is a compiler thing. I imagine the compiler looks here first or something like that.
Right.
Okay, so let's see where I think that's a good question, where this is set. LED sequence, animation, LED driver.
Search is the worst search. It's probably this one, Jewelbot types.h.
Yeah, there we go. So this is.
Here it is, line 42.
Yeah.
Type destruct. So I guess it's saying that LED command T is the name for a struct with these 5 fields, it sounds like.
Yeah, exactly. It looks like this is something we wrote ourselves. This is not, I did not write this.
Yeah, I get it. I get
Yeah.
it. Just the name
So
seems to go after the.
okay, so the LED driver, to go back to this function.
Oh yeah.
Here we go, LED state handler. Okay, so it's looking, so it's going through this case statement to see which LED
Mm,
that we're
mm,
referring to, and it
mm,
all comes down to this function here, the SPI send receive. So
mm,
this function is basically in everything and every part of the device.
mm,
It's what sends information from the microprocessor to what you would kind of consider a peripheral,
mm,
whether it's the
mm,
haptic motor or an
mm,
LED,
mm,
or the Bluetooth. This is how it sends messages back and forth.
mm. What does SPI stand for?
I don't remember. However,
Should we Google it?
um,
SPI.
just
Okay.
to show you,
Serial peripheral interface.
yep, that makes sense. I just want to show you the, no. It does have its own version of Stack Overflow. I think this is one of, it might be when, no, this isn't.
No, this isn't Stack Overflow. But yeah, we did sell Stack Overflow years and years ago.
Yeah,
Yeah.
I think they originally had one of those, but this is new. Um, anyway, so this is sending and receiving serial peripheral interfaces. So it's sending information and receiving information. Looks like it's just sending right now to the
Mm-hmm.
LED. So and basically it's breaking down that state.
Mm. My guess is that maybe that the third argument is how you send, and then if it was one, it would be receive or something like that. That's
I
complete
believe so.
guesswork.
Yeah, because it seems like all of them have two. Yeah. So to go to the pull request that we're going to look at. So
Mm.
let's look at the colors, where the colors are set. So LED colors. So none of these are a function. These are just defining what the colors
Mm-hmm.
are.
Mm-hmm. Mm-hmm.
So we had a really fun time when the new colors came out, working with the community, figuring out what to name them.
Mm.
So we'd like take a picture of the lights on and say, what color is this? And we get all kinds of opinions.
Periwinkle, that's a nice one.
I know, yeah. So this got added a few months ago. And once this is added, there's a function called breathe where the device looks like the lights are coming on slowly and turning off slowly.
Uh-huh.
That didn't support the new colors yet.
Uh-huh.
And so that is what that's the first thing we're going to be testing today.
Mm-hmm.
So let's take a look.
Oh,
So
okay,
this,
someone's already done this.
yeah. So this is someone actually that doesn't have a Jewelbot, so wasn't able to test it.
Right, 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 right.
And so that's what we'll be doing today.
Mm.
Is testing to see if this works. So why don't you, if you can,
Yeah, send me send me a link to the repo and I'll pull it
yep,
down.
yeah. And did they do it on both or just this one? Let's see. Because if they did it on both, we should use the other one.
Okay.
No, just this one. Okay.
No.
So I'll put this in Slack. Nope, that's title.
Thank you.
And then I will let you share your
Uh,
screen when you're ready.
yeah. Oops.
You could probably use Visual Studio as an idea. Well, you could definitely use Visual Studio
Yeah,
Code.
let's try Visual Studio Code to start with, because it's got the share thing, and
Oh
I've
yeah.
turned off my VM, but that seems to work pretty well, the live